Hello and welcome. This is my mobile tech demo. What we've got here is well, first I'll say, did I bite off more than I could chew? Yeah, probably. But here we are. So this is my effort to automate the AeroPress coffee maker. So that's the device you see in front of me, without all this, obviously, just this guy here. You put coffee in it, you put water in it, you give it a stir, and you push the plunger down, and your coffee comes out the bottom in a cup. Make some real nice coffee. So I was like, can we automate this? Yeah, I think we can give it a good go, and I think that's what I've done here. So we'll take a run through all the parts. So it's pretty modular. Obviously, the end goal is to miniaturize, get all this on the one rig, hopefully make it half portable and not kind of. This is a prototype. We'll call it a prototype. So you've got the grinder over here. Grinds coffee beans onto the scale. Read the weight. When it hits X weight, switch it off. We've also got the kettle. We've got a little temperature probe in there so we can watch the temperature. We've also got a screw, it appears. There's the tube to take the water out through the pump, which is just sent at the back there, into the AeroPress itself, and then the actuator to actually do the pressing. Let's take a little look at the controllers here. So we've got a Raspberry Pi on the right hand side, Arduino, then a little breadboard, power supply, and a little relay board there as well. There's another little board just here. This is a amplifier board. I'll speak about that in a second. So the Pi is running a Node.js server. So this project, I've tried to keep it as JavaScript based as fully possible because it is the language of the web. It is the future, and yes, it was a learning curve. So it's running Node.js. Great stuff. The Arduino has a firmware package called Formata. This allows injection into its run loop, so I can call functions that are not in the sketch that was loaded to it. This is all done through a JavaScript wrapper from the Node.js server running on the Pi. That's known as Johnny 5, and it's really excellent. Got great support, loads of JavaScript classes, kind of just a pick up and go. However, one thing it doesn't have support for, unfortunately, is this HX711 amplifier board and the load scale, the load balance in the scale here. So as it stands, this is running. It's actually running a C library. Again on the Pi, but not in the same thread as the Node server. It's completely separate. However, it tends not to affect things because of the way I've set up the back end, which I'll tell you about in a second. In fact, let's do that right now. So let's jump over and take a look at the software here. So this is kind of the landing page, your kind of classic one-page application. I could be doing this from my mobile phone. As you can see, it's responsive, fits on the screen nicely, get all the same data, all the same controls. In fact, when I'm not filming this, I actually prefer to use it on my phone, just because I can stand right next to all the gear and make sure that it's all working like it should. Anyway, this whole thing is running. It's almost a mean stack. I don't use MongoDB. Instead, I'm using Firebase, which we'll look at in a second, and the reasons why I'm using it. This is running Angular. So the front end is AngularJS running on an Express.js server, and again on a Node backend. So this is actually live right now. This is on a DigitalOcean droplet. So none of this is local. This is all actual online Internet of Things happening right here. So let's have a little look at what we can do. So we've got some manual controls here. So if you want to do some manual brewing, for example, you can switch the kettle on. You'll see that the relay board has triggered there, and you can see that the kettle is now boiling away. So that's nice. Over and above that, we've got manual control for the grinder, we've got the pump, we've got the press itself. The real nice thing about using Firebase, which is my back end, is it allows us to do what's known as a three-way data binding. So the Raspberry Pi is actually watching these variables. So for example, we can see we've got the kettle on just now. So if we change this back to true in the database, we hit enter, the Raspberry Pi is watching that. It's then switched it off, so the kettle is now off. And not only that, this is three-way data binding, remember, so not just between the Pi and the database, but also the front end. So you can see that this has switched back to off. So that's the real reason of using Firebase, is really tightly bound data structure. And on top of that, you're talking full API RESTful here. So all of this could be posted to. For example, as far as other inputs are concerned, literally anything. The back end is done because it's purely reliant largely on Boolean values. And of course you've got temperature and you've got weight. You can query all this from the API, meaning, I could write a Python script to interact with this. I could write whatever, something in Ruby. You could have anything because it's fully RESTful, which is really cool. Anyway, brew profiles. So we've got coffee, we've got espresso. They're just both here displayed at the moment. So this was a challenge. JavaScript really, 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 really does not like synchronous execution. Obviously, Ajax and everything is asynchronous in the name. So to get this to chain a series of events, so essentially what the profile is, it'll load and actually run the whole coffee brew process, if you like. So, this is thinking ahead when, we're shooting for like a one button press coffee here. We're not quite there yet, but we're close. So let's give it a bash. So we've loaded the coffee profile here. We'll hit start brewing and we'll watch the whole thing work, hopefully. Got a little buffer there. I think I did click it. So the grinder comes on there. I think it's until, what's the profile? 20 grams of coffee. So we got a coffee. And see, this is the manual stage at the moment, which is a bit of a nuisance, to be honest. But it's really not easy to move powders and things. What it is easy to do is get coffee everywhere. Okay, so I messed with most of that, but it's in there. It's in there. So now we got to make sure that the hose is in for the pump, and then here we go. It's given us a alert here. Please fill the AeroPress with coffee. I've done. Hit continue. So what this does here is, it checks the water temperature. Because we're boiling it earlier, you can see that the temperature is already 83 and the brew profile states for 80. So that's good to go. It checked that and then automatically started the pump. As you can see, it's now filling the AeroPress with water, and let's all pray that it actually stops before there is no water. Oh, thank God. And I don't know if you hear that there, but it's actually started the actuator. So it's now gone straight into the pressing phase. And this takes a little bit of time. We've got some pulse width modulation here. So I think this is a 280 second press. So it's going to take 280 seconds. You've got to make sure you've got a cup underneath. And I don't know if you can see, there's the product. That's why we're doing this. So that's kind of it all in. There was a lot of problems. There was a lot of things. I wouldn't use a Raspberry Pi again in a hurry, to be quite honest, for this purpose at least. To get a lot of the software I needed to work on it, I required to compile it. I tried to cross-compile it. That didn't work. It was basically a massive time sink. Anyway, I've just hit the 10-minute mark, so I think you can see what I'm all about here. I think you can see what I've tried to achieve. We'll leave that with it pressing out. But yeah, hope you like it. I know it's turned into a bit of a passion project for me personally, but hey, here it is. Thanks.